Hello class, today we're going over lesson 1.3, how to compare and order real numbers. So let's start off with a definition here. What is a real number? So a real number is all rational and irrational numbers and everything that those numbers encompass as well. We got a chart down here to show us basically. But right here we see that this big huge circle is real numbers, the one that encompasses everything. Then we have two smaller circles inside of that. One is rational numbers and one is irrational numbers. So we've already learned that an irrational number is just a number that cannot be written as a fraction, whereas a rational number is a number that can be written as a fraction, where the denominator is non-zero. And then obviously, as we've learned in past years, integers are also rational numbers, as are whole numbers. However, everything, including irrational numbers, rational numbers, integers, and whole numbers, are all considered real numbers. And then we do have numbers out there that are not real numbers. Those are actually called imaginary numbers. But we're not going to learn about this year at all. Those would be learned in high school. Just know that real numbers are both rational and irrational numbers. And basically, they tell us that if it's a real number, it can be graphed on the number line. All right, everybody. So our goal today we're going to work with ordering all the numbers we have come across so far. We will be able to do this using approximations and also a little bit of common sense. All right, so can we approximate a non-perfect square using perfect squares? So we want to approximate the square root of 32. So what it really means when we do this is we want to have a square or a perfect square that is both above and below this number right here. So what we want to do is we want to find something that's just kind of a perfect square that's above this here. Well, I know the square root of 32 has to be less than the square root of 36, right? Because 36 is a larger number than 32. And I do know that 36 is a perfect square because the square root of 36 here is going to be 6. Now, if I want to choose a number on the other side here, I could tell that the square root of 32 has to be greater than the square root of 25. The reason I know that is because the square root of 32 here, or 32, is a larger number than 25, but also the square root of 25 is equal to 5, so that helped us here. So what are we saying here? We're saying that the square root of 32 has to be somewhere in between 5 and 6, and probably a little bit closer to 36, so a little bit closer to 6 here. So if we go to our calculator and do the square root of 32, we would get 5.66, which again is a little bit closer to 6 here. But we were able to do that using two different square roots or two different perfect squares that we knew, and we approximated the one in the middle. So again, we chose the square root of 36 because 32 is slightly less than 36. It's the next largest perfect square. And then we chose 25 because that's the next smallest square before 32. So we get that 5.66 is equal to the square root of 32. All right, we want to locate and plot the square root of 15 on a number line. All right, so to start this off here, let's do some approximations. Let's take the square root of 15 here. Obviously, we know this is going to be less than the square root of 16, right? Because that's a number 1 larger than it. We also know that it has to be greater than the square root of 9, because 15 is larger than 9. So if I'm on a number line here, we know that the square root of 9 is equal to 3. We know that the square root of 16 is equal to 4. So we're saying that our square root of 15 has to be somewhere in between these two numbers because it's both greater than 9 and less than 16. So since 15 is a lot closer to 16 than it is 9, I'm going to plot my square root of 15 over here a little bit since it's closer to the 4 or the square root of 16 than it is to the 3, which is the square root of 9. And then let's double check this on our calculator here. What do we get when we take the square root of 15? We would get 3.87, which is, again, a lot closer to 4 than it is to 3. So the way we did this here was just approximating it using our square roots, and then we graphed it on the number line. All righty, let's do one more example for us here. We want to compare negative 1.9396312, and the square root of, or negative the square root of 5. All right, so we know that the square root of 5 here, or negative square root of 5, let's just focus on the square root of 5 first. The square root of 5 is going to have to be less than the square root of 9, but also greater than the square root of 4, right? So since the square root of 4 is equal to 2, we know the square root of 5 is greater than 2 and less than 3. Whereas with this number here, we know that this is a negative 1.96312. So we know that this number is technically, as a value, it's less than 2. However, since we're looking at negative numbers right here, this would be greater than 2. And again, since this is a negative number here, we can actually switch these around. Since all of these should be negative here, we could just switch our signs. So this would be a greater, 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 greater. So since the square root of 5 is greater than 2, as is the square root, or as is negative 1.96312. Geez, I can't say this right. 96312. We know that this is going to be greater than the square root of negative the square root of 5. And if we find the negative square root of 5. Yep. Alrighty, everybody. So that was what we learned in conclusion today. All we really did was compare some real numbers here, and also we found out how to order them. So make sure to watch this for your guys' video notes, and I will see you in class tomorrow. Don't forget that 2-sentence conclusion, everybody. All right, everybody. Peace out.